When solving log equations, there are two types. So this first type, everything has a log. So there's log base 5 of x minus 3, log base 5 of x, and log base 5 of 10. Second type is going to have logs, and then there will be something that's not a log as well. Methods for solving the two types are similar, but it's just at the end, when we actually have to get rid of the logs so we can solve this, that they differ a little bit. First thing I want is a single log on the left-hand side, and there already is a single log on the right. So typically you just want a single log on both sides. So on the left, because those two logs are being added, I know I multiply what I'm taking the log of. So log base 5 of x minus 3 plus log base 5 of x is the same as log base 5 of x minus 3 times x, and that equals log base 5 of 10. I'm just going to expand the x minus 3 times x, so it's log base 5 of x squared minus 3x equals log base 5 of 10. Now we have a single log on both sides of the equation. So when there's a single log on both sides of the equation, I just cross them out, or some people call this dropping the logs. Because it's an equation, we know they're equal. Because we're taking the log of both sides, then whatever we're taking the log of has to be equal. Because the log of, it can't be log 2 and log 4, it wouldn't be equal. So for this reason, we just get rid of the logs and solve x squared minus 3x equals 10. This leaves a quadratic, and typically with a quadratic, we want to get everything to the left-hand side, and then we can either factor or use the quadratic formula to solve. So x squared minus 3x minus 10, I'm going to use the AM method to factor it. So I'm looking for two numbers that add to negative 3 and also multiply to negative 10. Always look for two numbers and multiply to negative 10 first, and you should be able to figure out that it's negative 5 plus 2 and negative 5 times 2. So this factors as x minus 5, x plus 2 equals 0. To get my roots, it's always the opposite. I always go, what number minus 5 is 0? Well, 5 minus 5. What number plus 2 is 0? Negative 2. So x equals 5 and negative 2. With any log equation, you always have to check your solutions. So first I'm going to check x equals 5. So I'm going to do this by subbing 5 into the left side of the equation and just seeing that it equals the right side of the equation. So log base 5 of 5 minus 3 is log base 5 of 2, plus log base 5 of x is just log base 5 of 5. Because it's adding, I'm going to multiply those, and I get log base 5 of 10. Which is the right side, so these are equal, so 5 works. And now we got to check the negative 2, so I'm going to do the exact same thing. Okay, subbing negative 2 into the left side, I'm going to get log base 5 of negative 2 minus 3, which is negative 5, plus log base 5 of negative 2. Already I got a problem. One of the restrictions on logs, and we haven't really talked about restrictions on logs yet, is that you cannot take the log of a negative number. If you want to think about why, we'll just go 5 to what power would equal negative 5? Nothing. 5 to any power is always positive, so this is not possible. You cannot take the log of a negative number. So what happens is negative 2 is what is called an extraneous root. This happens in solving things algebraically quite often, especially with logs. It happens a lot in that you do everything right, you haven't done anything wrong, but when you solve it, you get an answer that's not possible. So we need to eliminate the negative 2, and our only solution is x equals 5. This is why we always have to check answers when solving log equations. A shortcut to check, instead of having to sub in and actually work out the left side and work out the right side, is that you can also just take your answer and see if if you sub it in, if it's going to be the log of a negative number. If it's going to be the log of a negative number, it is an extraneous root. If it's the log, if it works, that it's a positive, everywhere that you can sub in x, you're going to be taking the log of a positive, then that answer is going to work. For example, when I look at this original equation, and you always got to go back right to the start, when I sub 5 into the first log, 5 minus 3 is positive 2, good enough. When I sub it into the second log, it also works because I'm just putting in positive 5. When I sub negative 2 into the first one, well, negative 2 minus 3 is negative 5. As soon as I'm taking the log of a negative number, I'm done. That one is an extraneous root. Another way to check your solution is to graph it and find zeros. So I'm going to bring the log base 5 of 10 over to the left-hand side, and then I'm going to graph this on Desmos. So I'm graphing log base 5 of x minus 3 plus log base 5 of x minus log base 5 of 10. And then the only zero is 5. On a graph, extraneous roots never show up. An extraneous root is something that only occurs algebraically. So when you graph it and solve it, it's a great way to check because the only solution is the one that you should be left with after finding extraneous roots.